Anyway, hello, my name's Evan. I'm chairman of UCC NetSoc, which is the technology society on UCC campus. I've been a web developer for about 6 years, and in that time I've had many sites get hacked and go down, and in various levels, with various levels of exploits. Some of them very embarrassing, to be honest, to go back to your client and kind of say, well, I forgot this one line somewhere, and now your entire site and all of your user data is gone. So, well, be grand. I do actually have notes, but I'm probably not going to read them. As you can tell, I'm not exactly I don't public speak very much. So you'll hear the quaver in my voice and, my shabby exterior is probably a clear sign of that. But anyway, I've worked with companies of various sizes, and I often drag them kicking and screaming into the 21st century, whether they like to be here or not. So what I'm going to talk about today are kind of three of the main basics of web security, which involve injection, cross-site scripting, and cross-site request forgery. I have to take a moment because they all have nicknames, which I'll bring up later. So to start with, I'll go through injection. So what injection is you're putting your own code in between the site and the user and getting it to execute malicious whatever you want, really. Generally, it's used to gain access to authentication. So the first thing any kind of lead hacksaw these days tries to target is the way you authenticate your users. Because if they can create their own account and gain access to someone of a higher stature, that's always a bonus, regardless of whether that actually leads to anything. It's a very worrying thing to have in your application. So you probably can't read a lot of the code snippets, but it doesn't really matter. I'm going to talk very briefly over them. I'm using PHP. I'm not going to specifically talk about anything in PHP, so you don't need to know PHP. I'm also going to talk about SQL, which is a query language for those who are not familiar with SQL. It's just there to insert and retrieve data from a database. But what you might use to authenticate a user is a simple form with the username and password. So what you'll be doing here is you're taking in the username, you're taking in the password, and you're just passing it into this SQL query, and I've isolated it here. And all it's doing is get this user by username Evan with password, my password, and if it comes back with a result, great, you log them in, that's all fine. If it doesn't come back with a user, well then, tough shit, they don't get logged in. But there is a significant problem in the way I've laid this out, because I'm taking the username and password directly from the user and putting it directly into my query. It leaves us open to some basic logic kind of exploitation. So there's these tiny little single quotes. I know they're a little hard to see, but what they say is anything in between these is the value I want to check against. So in this case, the username's fine, it's still Evan, but if we replace the password with something that has single quotes in it, it'll escape out of them, and it'll let us into the territory of the rest of the query. So we can now manipulate the query directly ourselves without prior permission from the original programmer. So our new query now, we've still got the same username, but we've escaped out of the query. We've added in an OR statement, which is just basic logic statement, and we've created a statement that's going to always be true. And that's the key feature here. Because it's always going to be true, we can log in as any user, because the password will always be true, so it'll always return the row with that username in it. And I'm sure you can see how that will be problematic. So it'll be true no matter what, and you can gain access to admin accounts as long as you know the username. The most famous example of that is Little Bobby Tables and his student database. So just to go through that example is I have the original query here, which is just insert into the student's database the name and the surname, and that's totally fine. We've got values Robert in tables if, his name was a little easier. But the way his name's set up is he has these two dashes at the end here. And what that says in SQL is those are comments. So anything after this, we'll just ignore it. It's not part of the code. It doesn't matter. So what you can do is you can escape out of the query, finish it up with a single quote, parenthesis, and a semicolon, and then you can execute a brand new statement. So in this case, what they're doing is they're dropping the table students. They're essentially deleting all of that information. You can imagine the school was a little unhappy about that. But to explain kind of like more in depth exactly what's happening, step 1 is we cap off the query, we finish it. Step 2 is we put in our own malicious code. And step 3 is we comment out the rest of it. We just put 2 dashes at the end, and anything else that the programmer put in suddenly doesn't get executed, and it just carries on as if normal. Actually, to explain why we need to put the comments in at the end is if I don't make a proper full statement, it might not execute any of the queries. It'll go through and kind of parse and make sure that everything's running fine, and depending on your database management system, it may execute them partially, maybe not. But generally, kind of like to be safe and make sure you do actually fuck with someone's website, you need to put the comments in at the end and be careful about that. Preventing injection kind of isn't too hard. Most kind of languages that interact with a DBMS really have methods and functions for this. So for instance, you can bind variables in prepared SQL statements so that they know exactly what type the variable has to be, what kind of parameters it has to meet, and it has certain criteria it has to fulfill before it even goes to the database, before it even starts executing it. We also have this kind of concept which is the least privileges necessary. So when you're interacting with a database, you have to have a certain user you're using. So if you give that user only the absolute necessary privileges it needs to do its task, then you're limiting the scope in which a hacker can kind of come in and destroy your data. Like, for instance, it would be like giving a coal miner access to a nuclear reactor if you didn't follow that. And would you trust someone with a pickaxe with your uranium? To move on to cross-site scripting, also called XSS, it mainly deals with things like JavaScript and embedding code into sites. But there are 2 main types in which there's reflective, where you can put data in and it'll show it to you, but it won't stay permanent. And then the second type is persistent, where it is permanent. It goes off to a database somewhere and stores your code, and every time someone logs on, they see that code, or you see that code, depending on the site. So just to talk about reflective first, or no. Sorry, I've actually gotten ahead of myself. But the main damage from it is you can steal users' session, you can hide code that gathers data in the background of sites that are more reputable, you can deface websites really easy, you can redirect to less savory sites like Meatspin or Blue Waffle. To speak about reflective SSS, there is a demo, but I have it just storyboarded because it's probably just easier really. But let's say that you have just a search form for a library and you're searching for a book. So what you do is you've got a little search form, you put in your query, but what we're going to put in is we're just going to put in some simple HTML. So it's just an underline. That's grand. It doesn't seem like that'll ever be an issue, but unfortunately, when we get our results back, it comes back underlined, which is kind of worrying because that means it's embedding our code in their website. It's really lazy programming. It's taking our direct input and directly putting it back on the web page. That's really, really annoying, but I suppose you're kind of concerned with, only I can see this. What's the point of that? Well, it gives us access to this wonderful URL at the end that we can share. So we can now put in JavaScript here, which is just a confirm dialog for the purposes of this talk. But we can put that confirm dialog in, and we can send this link to anyone. And anytime they open it, they'll see our code pop up, because what's happening is it's just passing all of our search query straight into a parameter in the code. I may skip around a lot. I'm sorry. Again, I'm not a great public speaker. So to talk about more persistent XSS, so imagine you have kind of like this personal stream. It's like a little chat room for you and your friends, and like you post a message, someone responds, you can boast about your coffee, your morning waffle, or whatever you want to do. It's just a little form again. And all you do is you share your update. So again, what I'm going to do is I'm going to just put in some underlined text to see, what comes out. And lo and behold, we've got the same problem again. They've not sanitized their input. They are getting a little bit smarter in the sense that they no longer let us put script tags in. But that's kind of irrelevant, because they think they're wonderful and great. But what I can do is I can get around that very easily by using very simple elements of HTML, which were created originally to handle errors, clicks, hover, etc., that we now kind of bind JavaScript to. But what you can do is you can create a malformed image tag, and you can give it an onError attribute. So every time an error occurs in that image tag, it'll execute whatever code we want. But it's a malformed image tag, so obviously it's going to always be broken. So every time someone logs onto this site, it'll go, okay, here's an image tag, let's render that. Okay, that didn't quite work. Oh, look, there's a little onError handler. Oh, that must be something they put in there for the programmers to, gracefully degrade the website. What it's actually doing is it's giving someone a handle on the website. And imagine if you could put a login form there. Imagine this was your bank, and you logged into your bank and it popped up with put in your username and your password and your PIN and your registration number or whatever. You're going to trust it because it's on your bank's domain, but it's obviously not their code, and you've no clue where it's going back to. And now with JavaScript kind of databases, you can easily take that information using JavaScript and send it off wherever you want. So preventing cross-site scripting, again, it's not kind of all doom and gloom. A simple thing is just avoid including user input directly in output. That's always the number one kind of faux pas people make, is it's really quick code, you just put it straight in, it's totally fine. But what you should be doing is you should be sanitizing and encoding all of your output. In PHP, you can encode any HTML element and it essentially gets rid of most of these problems. But you should also be kind of very wary of the fact that people find ways around this, or there's many ways in HTML, because it supports so many versions back, to actually exploit sanitization itself. So a great way to do it is actually just to whitelist input validation. So you can allow a certain number of tags, or you can allow a certain type of tag, but you won't allow all tags. So what I actually do is I actually whitelist nothing, which just means you're just stripping out all HTML. I'm not even trying to encode it. I guess I'm sanitizing it to the maximum degree. And then finally, I'm sure you're all very happy to hear, is cross-site request forgery, also known as session surfing, C-surfing. It has a host of different names, and everyone calls it something different. Everyone feels it's something different. What it essentially is you're using someone's logged in session to perform an action on their behalf that they don't want to do. So again, I'll go back to kind of the bank metaphor, I guess. If your bank allowed you to transfer money in a very vulnerable way, so I'm actually just going to go straight into the story. So Maria and Billy have played a poker game. Billy's obviously beaten Maria. Maria's quite kind of, she's pissed off. She wants to take all of Billy's money back, but doesn't really fully know how to do that yet. So she goes on to bank.com, which is what they're using to transfer all of their funds for the winnings. Maria figures out that like she can send Billy this link here, and what it'll do is it'll send €100,000 to Maria's account, and Maria won't have to do anything. She doesn't have to confirm it, and Billy doesn't have to confirm it. You just send him the link and it automatically processes the action. But like, you think no one's going to fall for that. It's obviously like a dodgy link. So why would you even bother sending it to someone? Well, it's actually very easy to get someone to execute something without really letting them know they've executed it. So what you can do is you can send them an email with, again, a malformed image, or not malformed in this case, but again with an image tag. And you can put the source as the URL we saw before. So now it makes a request to that URL with all of the data, all of the information that's in Billy's browser, including his cookies, including his sessions, and it executes the query straight off. It transfers €100,000 into Maria's account, and Billy's none the wiser. So eventually, after Maria's arrested as such for fraud and hacking bank.com, we can kind of get into preventing CSRF. So the most common way of preventing CSRF is to put a unique token on both ends of each transaction. It's actually very annoying to try and generate it yourself, and I would advise you use a framework to do it securely. A lot of frameworks do it now, like Django does it, WordPress does it itself, Laravel does it, things like that. Well, what's also a good method is require a secondary affirmative action. So you either there and then prompt them with, hey, this is going to delete your account. Do you really want this? Or you can actually send them an email with, we just deleted your account. If this wasn't you, you can click this to reverse it, or you can ignore this email and we'll delete it in the next 14 days. And be very, very aware of exposing your unique token. The best unique tokens are one use only, but make sure they have an expiry time and make sure they can't be replicated. And please do never, ever, ever expose them over any HTTP headers or anywhere on your site unless you know for absolute certain that they are one use, very short expiry time, and no one can use it to replicate the data. And that's kind of it. Thank you. So, yeah. Does anyone have any questions? No, great, wonderful.
There's a question in the back there.
Oh, yeah.
Sorry, have you ever tried using CSP headers?
No, actually I haven't.
So like CSP headers are kind of relatively new. So I think it's IE11 plus.
Yeah.
So IE9, 10 are screwed. But it allows you to on your server like set headers for certain things. So image tags, source tags, styles, and you can set a source for those kind of things. So you can like whitelist only certain domains are allowed to run script on your site. So that kind of prevents the cost of scripting as well. So like someone can't, like in a comment section of the site, add in malicious JavaScript. So you can set the whitelist that like it'll only run JavaScript that's on your site from certain domains.
Yeah.
But it breaks down so you can do it at like image levels, script style tags, image tags, script tags, and also WebSockets and stuff. So it's kind of another layer you can do for process scripting as well.
Yeah, that sounds awesome. Is that kind of like on a web server level, like Apache Nginx, or?
Yeah, so like in IIS, you set like the web config file. You just set like your headers, and that's it.
Yeah, it's actually into that.
And you can also kind of do cool stuff like there's a report only mode, so you can get it to like it won't actually stop the script running, but it'll send you a report of what scripts it will stop. So like if you want to do it at production level, you can set it to report only. You can get a report of all the domains that are being hit on your site, and then you can see once you're happy with you have your proper whitelist, you can set that and take away the report only.
Yeah, that sounds good. Yeah, like I guess the situations in which I'm using a lot of this stuff now is very kind of like as NetSoc we let users onto all of our servers, so it's very hard to maintain a whitelist of that size. But that's amazing, and I would like to incorporate that in clients and stuff.
Really
yeah. Cool. Okay, thank you very much.
Sorry, just one more. I don't know about other people. Thanks for the talk. You said 6 years ago you made a lot of mistakes. Imagine, or I can say I don't know anything about what you talked about, but it was very interesting. I'm interested in your learning resources. Where do you go to if you want to? You've just heard of this new risk or something. Where do you go to find ways to prevent this security issues?
Well,
is there a website, or do you have a textbook or something?
Well, if you mean just stuff in general,
yeah, just
like W3 Schools actually has a really good resource for pretty much all web security. They go through it in like a great depth, and they show you examples of things, and they give you interactive tutorials and stuff, and it's really nice. Generally, kind of the best way you ever learn is just when things go wrong and you give things to people. Like for instance, I'm a third year in computer science, and when I came into computer science, the best way you learn to sanitize all of your inputs and to prevent SQL injection is when you give it to 113 trigger happy computer science students and let them have a free reign on a chat application. Like, it's the best learning experience you can ever do, and I encourage you, if you ever find a group of people who are willing to tear down your application, that's the best way you're ever going to learn.
Is that your idea of guerrilla testing?
Well, we have other methods, but generally for anything that's student focused, I give it to a couple of friends of mine who are very good at finding the tiniest nooks and crannies where you've forgotten something and just unfolding from there.
Okay.
Yeah.
Thanks.
Another resource is OWASP, Open Web App Security.
Yes,
something.
yeah.
They have a lot of resources on those attacks and this and
They do talks with CorkSec actually, I think, pretty regularly. But yeah, they've also got a VM set up with actually like a set of tutorials and showing you at each step where the problem is, and they do packet sniffing and everything. It's great. Love OWASP actually.
Sorry. I want to ask about SQL injection. Is there a way to inject MySQL databases?
No SQL. Probably is. Like, there's probably I don't use NoSQL myself, unfortunately, but there's generally a way to do it in anything, like whether it's just interacting with a database or whether it's passing arguments to another command or something like that. If you improperly accept inputs, it's very easy to just kind of like, comment out the end, close off whatever statement you're making, and then put your own stuff kind of in the middle. So I imagine there is, but unfortunately I don't use NoSQL, sorry. Anybody else? Yeah.
Yeah, just another resource one. Tryhunt.com. He's like he was an MVP for Microsoft, but he's like a security guru, and he blogs like every week about security stuff, and it's a great resource. And he's a lot of videos on Pluralsight, like courses about how to hack your own site and stuff. So he has sites set up where he has vulnerabilities in them, and he goes through how to actually hack his own sites. It's a very good resource.
What's the name again?
Tryhunt.com.
Thank you.
Great. Okay. Thanks very much, Evan.